Hi, my name is Kelly, and I'm doing my class reading presentation on Humanity in a Cosmic Context, chapters 3.1 and 3.2 in On the Future by Martin Rees. In these sections, Martin Rees places humanity within a much larger cosmic perspective. Rather than focusing only on Earth, he expands outward to consider the origins of matter, the scale of the universe, and the possibility of life beyond our planet. His main argument is that Earth is both fragile and unique, and that even though the universe is vast and filled with planets, we still do not know whether life exists anywhere else. Rees begins with two well-known images, the Earthrise photograph taken during Apollo 8, which is on this slide, and the pale blue dot image captured by Voyager 1, which will be on the next slide. These images are important because they visibly change how we understand Earth. Instead of seeing it as large and central to our lives, we see it as distant and extremely small. As Rees emphasizes, the Earth is the only world known so far to harbor life. This idea highlights how rare and valuable our planet is. Rees builds on this idea by emphasizing that everything we know, every human life, every historical event, has taken place on this single planet. He reinforces Carl Sagan's point that there is no indication that help will come from elsewhere. This means that humanity cannot rely on outside solutions. Instead, we must understand our situation and take responsibility for the future of Earth. And as you see, I pointed out Earth in this photo. Rees then connects this perspective to the concept of deep time. Referencing Darwin, he explains that life on Earth has developed over extremely long periods. However, Rees expands this idea further by placing humanity within a cosmic timeline. This means that human existence is only a small part of a much longer process that includes the formation of planets and stars. One of the most striking points in the text to me is Rees's explanation of where the elements that make up life come from. He explains that stars act as nuclear fusion reactors, producing elements like carbon and oxygen. These elements are released when stars die, and then are recycled into new stars and planets. This leads to his statement that we are literally the ashes of long dead stars. This idea connects human life directly to cosmic processes, showing that we're not only separate from the universe, but deeply a part of it. One thing Rees is doing here that is easy to overlook is that the scale of the universe actually changes how we think about importance and significance. When he describes billions of galaxies, each with billions of stars, he's forcing the reader to confront how small Earth really is in comparison. At the same time, though, he doesn't say that this makes Earth unimportant. Instead, it has the opposite effect. Because Earth is the only known place with life, its importance actually increases. So there's a kind of tension here between smallness and significance. Even though cosmically we're small, we're still uniquely valuable because we are the only known example of life. Rees also emphasizes the enormous scale of the universe. He explains that our galaxy contains over 1 billion stars, and that there are billions of galaxies beyond that. This vast scale makes Earth seem incredibly small. At the same time, it suggests that there are many opportunities for planets to exist elsewhere, which leads directly to the question of life beyond Earth. This brings us to the most important question in the text. Are we alone in the universe? Rees explains that recent discoveries have shown that most stars are orbited by planets. This means that our galaxy is not unique in having planets, and that there may be worlds with similar conditions. Rees describes how the discovery of exoplanets has transformed the field of astronomy. Since the 1990s, scientists have detected thousands of planets orbiting other stars. This confirms that planetary systems are common, not rare. This discovery supports earlier theories that planets form naturally as part of star formation. He also explains how these planets are detected. One method involves observing the slight movement of a star caused by the gravitational pull of an orbiting planet. Another method involves measuring the dimming of a star's light when a planet passes in front of it. These techniques are important because they allow scientists to study planets that cannot be seen directly. It's also important to note that these detection methods show the limits of human knowledge at the same time as they expand it. Rees emphasizes that we are not actually seeing these planets directly in most cases. Instead, we're inferring their existence based on very small changes in light or motion. This means that a lot of our understanding of the universe depends on interpretation and indirect evidence. So even though technology allows us to discover new planets, it also reminds us that our knowledge is still partial and constantly developing. We are building an understanding of the universe step by step, rather than observing it perfectly. Rees then discusses the idea of habitable planets. These are planets that exist in a Goldilocks zone, where temperatures allow liquid water to exist. He explains that there may be around 1 billion Earth-like planets in our galaxy alone. However, even if a planet is Earth-like, this does not guarantee that it supports life. Despite these discoveries, Rees emphasizes that there is still a great deal of uncertainty. He states clearly that we just don't know whether life is common or rare. It is possible that life emerged only once under very specific conditions. On the other hand, it may be a natural outcome whenever the right conditions exist. Rees also suggests that life may not necessarily look like life on Earth. He discusses the possibility that life could exist in very different environments, such as the methane lakes on Titan. This expands the definition of what we consider a habitable planet and suggests that life could take many different forms. Looking forward, Rees explains that new technologies will allow scientists to study the atmospheres of distant planets. Telescopes like the James Webb Space Telescope and the Extremely Large Telescope will be able to detect chemical signs that could indicate the presence of life. This represents a major step forward in answering the question of whether we are alone. This is where the reading connects even more clearly to the course idea of technology as an environment. The telescopes and instruments that Rees describes actually shape what we're able to know about reality. For example, without telescopes like Kepler or the James Webb Space Telescope, we would not even know that exoplanets exist in such large numbers. In that sense, technology creates a kind of informational environment that expands human perception. At the same time, this also connects to the idea of speed, because these discoveries have accelerated rapidly within just the last few years. What took centuries of speculation is now being answered within years through technological advancement. This reading connects to several concepts from our course. Technology acts as an environment by shaping how we understand reality, especially through images and data from space. It also reflects speed, since scientific discoveries are happening more rapidly than they ever have before. Finally, it connects to futurism, as it focuses on future possibilities such as discovering life beyond Earth. These ideas are reflected in contemporary culture in many ways. For example, as I said, NASA's James Webb Space Telescope is currently being used to study distant planets. Private companies like SpaceX promote the idea of space exploration and future human expansion. Additionally, media and entertainment like this movie, Arrival, frequently explore the idea of alien life, showing how this question continues to capture public interest. Looking more closely at these examples, we can see how Rees's ideas are reflected in both science and popular culture. For instance, the James Webb Space Telescope is already being used to analyze the atmospheres of distant planets, which directly relates to Rees's discussion of searching for chemical signs of life. At the same time, companies like SpaceX promote the idea of space exploration and even colonization, which shows how these scientific ideas are influencing real-world ambitions. In addition, media representations of aliens and other planets often simplify or exaggerate these possibilities, but they still reflect the same underlying question that Rees is asking: whether life exists beyond Earth. So these examples show how scientific concepts in the reading extend into broader cultural and technological discussions. Rees's argument is strong in that it is grounded in scientific evidence and clearly explains the current state of knowledge. However, it also highlights the limits of that knowledge. By emphasizing uncertainty, the text raises important questions, but does not provide clear answers. This can be seen as both a strength because it reflects honesty and a limitation because it leaves many issues unresolved. Another important point that Rees raises indirectly is how much of this discussion is still unresolved. Even with all the technological progress he describes, we are still at a very early age in answering these questions. The fact we cannot determine whether life is common or rare shows the limits of current science. At the same time, it also highlights how important future discoveries will be. This uncertainty is ultimately what drives continued exploration and research. In conclusion, Rees presents humanity as part of a vast and complex universe. Earth is small, but uniquely suited for life, and it remains the only place where life exists. While the discovery of exoplanets suggests that other habitable worlds may exist, the question of whether life actually exists elsewhere remains unanswered. This uncertainty makes the search for life one of the most important scientific questions today, and it also reinforces the importance of understanding and preserving our own planet. Thank you for watching my presentation.